નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Today in Standard 10th, subject Mathematics, we are going to learn Chapter 13, Surface Area and Volume. Today in Chapter 13, Surface Area and Volume of Standard 10, we are going to talk about some of the formula of cuboid, cylinder, cone, sphere, hemisphere, frustum of a cone. So let us take one by one. Let us revise this formula. Already we have studied in standard 9th. Now first of all, lateral surface area of a cuboid. Lateral surface area of a cuboid is equal to 2 times L plus B multiplied by height. That is perimeter of the base multiplied by height. Is you can see the cuboid. Perimeter of the base multiplied by height. We will get the lateral surface area of the cuboid. Then total surface area of cuboid is equal to 2 times length into breadth plus breadth into height plus height into length. So that is area of front side and the back side, area of top and bottom, area of left side and right side. So here length into breadth, that is area of the bottom and the top. So 2 times this, same way 2 times this and 2 times this. Then volume of a cuboid, length into breadth into height, that is area of the base, area of the base multiplied by height. Here perimeter of the base multiplied by height, here area of the base multiplied by height. Same way chord surface area of cylinder. Chord surface area of the cylinder, perimeter of the base, as the base is circular here, perimeter of the base multiplied by height. Then total surface area, that is equal to chord surface area plus area of the top and area of the bottom. So here chord surface area plus 2 times pi r square. So 2 pi r common, so we get h plus r in bracket. Volume of the cylinder, that is area of the base multiplied by height. So area of the base is circular, so pi r square h. Now suppose the cylinder is hollow. There is a hollow cylinder. Hollow cylinder you can see here, that is cylindrical any vessel if you take, it's some edge you can see, boundary. Inside it is hollow, completely it is hollow, but here there is a thickness. Same way both the sides, here you will find thickness, that is hollow cylinder. So here for hollow cylinder having external radius, you can see the external radius capital R and internal radius is small r. Internal radius is small r and the height is h. So what is the chord surface area of the hollow cylinder? So as it is hollow cylinder, area of this as well as inner surface, outer surface as well as inner surface, that is called chord surface area. So external surface and internal surface, that is outer surface and inner surface area and outer surface area. So here it is 2 pi r h, r capital, and here radius is small, so 2 pi r h. So 2 pi h common, so capital R plus small r in bracket. Now if you want to find the total surface area of this, so for total surface area, here you can see this boundary is not this much, here only some portion you can see here, this much thickness, it is thickness here, this boundary, this thickness is there. So that area of this part only we have to take, not the whole part. So how to find the area of this? So this is what, nothing but here 2 circular parts you can see. This is just like, this is circle and this part is circular. So we have to find the area of this region only at the top. At the same time bottom also same thing. So here first of all chord surface area of the hollow cylinder plus area of the base ring and the top too. So here chord surface area is given by this formula. Here area of the base ring you can see now, pi r square. This is total area is pi r square minus this area, that is small pi r square with small value of r. So here total area of this and then minus area of this region, then you will get area of this shaded region, that is ring. So at the top edge, at the same time at bottom also. So here 2 times pi r square minus 2 times pi r square. So in this now, here 2 pi h common, here 2 pi common, so r square minus small r square. So here you can see pi r 2 pi h in bracket capital R plus small r. Here pi 2 pi common, so capital R minus small r. So when we expand this using identity, it is capital R plus small r multiplied by capital R minus small r. So here this is common, r plus r common, and also 2 pi common. So we have written here, you can see, that is 2 pi common and r plus r common. So here what is left? H, and here what is left? Capital R minus small r. So we can write this formula also for total surface area of the hollow cylinder. Now volume of the hollow cylinder. So what is the volume of the hollow cylinder? External volume minus internal volume. Here if the cylinder is like this hollow, then external volume including outer side and internal volume, then we'll get the volume of metal used for this hollow cylinder. There is a hollow metallic cylinder, then how much metal is used. So we can use such formula, external volume minus internal volume, that is pi r square h minus pi r square h. Here capital R, here small r. So pi h common, capital R square minus small r square. So this is regarding hollow cylinder. Now curved surface area of cone. Cone is we have studied last year. Here you can see height, radius and the slant height. So pi r l is the curved surface area of cone, where l is a slant height. So l square is equal to h square plus r square using Pythagoras theorem for this triangle. And l is equal to square root of h square plus r square. Now total surface area of this cone if you want, then curved surface area plus area of the bottom, that is base. So pi r l plus pi r square. So pi r common, so in bracket l plus r left. So that is regarding curved surface area of cone. Then volume of cone. Volume of cone is generally the volume cone is having volume 1/3 of that of cylinder. If we take 3 cones of the same radius and height, then it is equal to the volume of cylinder. Therefore 1/3 of the volume of cylinder, that is 1/3 pi r square h. Now comes sphere and hemisphere. So surface area of the sphere, you can see the sphere. Surface area of the sphere is 4 pi r square, and volume of the sphere is 4/3 pi r cube. Now curved surface area of the hemisphere, if hemisphere is there, then curved surface except the area of the top. So this is the curved surface, that is 2 pi r square, and total surface area of the hemisphere means curved surface plus area of the top, circular top. Top is circle, so area of the curved surface area pi r square plus here top is circular, so it is pi r square. So it is total 3 pi r square is the total surface area of hemisphere. Then comes volume of hemisphere. So volume of hemisphere is half of the volume of sphere. So that is 2/3 pi r cube. So this is regarding volume of sphere and hemisphere. Now we have to take the formula for frustum of a cone. Now lateral surface area of the frustum of a cone is pi in bracket r plus r bracket over multiplied by l. So here just like cone pi r l, but here there are two radii, top and the bottom. As you can see here, the top radius is larger than the radius of the base. Here it is just cylinder is having both the radii same, top and bottom. Here the radius of the top and bottom are distinct, that is frustum. So here lateral surface area in that L, slant height, L square is equal to h square plus r square in case of cone. Here it is L square is equal to h square plus square of the difference, that is r square, r minus capital R minus small r whole square. Then total surface area of the frustum of a cone is here lateral surface area plus area of the top plus area of the base, area of the top and base. So here lateral surface area is same as here pi in bracket sum of the two radii multiplied by slant height plus area of the top. Here radius is capital R, so pi r square. Here radius is small r, so pi r square. Then volume of the frustum of a cone. So just like volume of a cone, 1 by 3 of the volume of cylinder. So 1 by 3 of pi r square h, but here r square is capital R plus small r whole square, like, but here it is capital R square plus r square plus r into r, not 2 times r into r, but r into r. That is, one is radius of the top and the other one radius of the base. So these are the formula for frustum of a cone. So now using these formulas, we have to go for the surface area and volume. Earlier in 9th standard you have studied all these things. Here frustum of a cone is one new formula for you. Here we are going to talk about the questions just like 9th standard, but here the reference is there we used to have only one solid. Now here we are going to find the surface area of combination of solids. So more than one solid is there and we have to find the surface area for that. Here you can see there is a cylinder having two hemispherical ends. Instead of circular end, there are hemispherical ends. So whenever we want to go for the curved surface area, then we have to find the curved surface area of the cylinder plus curved surface area of this hemisphere plus curved surface area of this hemisphere. But whenever we want to find total surface area is asked, then we have to find curved surface area of cylinder and surface area of these two hemispherical ends instead of circular ends. Same way, whenever we want to find the surface area of this solid, so we have to go for the curved surface area of the cone and curved surface area of hemisphere. Instead of the circular base, here the base is hemispherical. So we have to find the curved surface area plus area of the base, but area of the base here is hemispherical. So curved surface area of hemisphere, then we will get the total surface area of the solid. So this type of questions are there in this chapter. So let us start illustration 1. Here Rashid wanted to color the plane top. Here top is there with that is conical in shape having hemispherical top. So plane top with crayons you want to color. Now the top is in the shape like a cone surmounted by a hemisphere. It is a cone surmounted by hemisphere. Entire top is 5 centimeter high. Height of the entire top 5 centimeter from here to here. But here you can see this is the cone. So now diameter of this hemispherical top is 3.5 centimeter. It is diameter. Diameter is 3.5 centimeter. So radius is 3.5 by 2. So this is also radius and this is also radius. So this radius is 3.5 by 2 centimeter. And then we have to find the area of this solid that is to be, or the top, plane top that is to be colored. So find the area he has to color it. So we have to find the height of the cone also, as the total height is 5 centimeter, but the height of the this height, that is radius of the hemisphere, is 3.5 by 2. So what is the height of the cone? That is 5 minus this height, then you will get the height of the cone. So let us start. First of all, here the radius of cone or hemisphere, both are same. That is equal to r, and that is equal to 3.5 by 2 centimeter. Now height of the cone, height of the cone is equal to h, and that is equal to here total height minus radius, and that is 3.5 by 2 centimeter. So 5 minus 3.5 by 2 centimeter. So on simplification, here we will get 10 minus 3.5 divided by 2, that is 6.5 divided by 2, and that is 3.25 centimeter. 3.25 centimeter. Now also here we are going to talk about now area to be colored. That means the surface area of, that is curved surface area of cone and curved surface area of hemisphere. So that is the total surface area of the top. So for curved surface area we want pi r L. So we need slant height. This is the slant height, and for this radius is there. So that is given. So how to find the slant height? Therefore here we can find the slant height of the cone, and that is L is equal to square root of here square root of height square plus radius square, and that is equal to square root of. So here what is the height? Height is given 3.25 whole square plus radius. What is the radius here? You can see it is radius is 3.5 divided by 2 whole square. So let us find out the solution for this. So we will get the slant height. So now you can see 3.25. So now when we go for 3.25 whole square, so what is the here when we go for this 3.25 whole square, when we simplify 3.25, that is 325 divided by 100, when we cut off we will get here 13 by 4 whole square plus 3.5 means that is 35 square divided by here 0.1 decimal place, so divided by 20 square, that is 400. Directly we can take square. Here 13 by 4 means here we can get 13 square, that is numerator is 169 divided by 4, that is 16. So now we can take LCM here. So when we take LCM, what will be the LCM? You can see here to find the slant height. Here we have to go for the simplification of this. So now 169 divided by 16 plus 1225 divided by 400. When we take the LCM, here we will get the denominator is 10,000. You can see here 16 multiplied by 625, and this is multiplied by 25. So when we multiply 1169 multiplied by 625, then we will get here 10,000, 1,05,625 plus when we multiply this by 25, 1225 multiplied by 25, then we will get here multiplied by this is multiplied by 25. So we will get 30,625, and so therefore we will get the slant height is equal to square root of here numerator. On adding this numerator we get 1,36,250 divided by 10,000. So on simplification, finding the square root of the numerator, here you will get 3.691, that is 3,691 divided by 10,000. So up to 4 decimal places we will get 3.691, and that is here we say approximately it is 3.7 centimeter. So this is approximate slant height. So now our question is to find the area to be colored. So area of the, therefore this now area of top to be colored is equal to total surface area of the plane top, and this plane top is having two things, that is hemisphere and cone. So here that is equal to curved surface area of hemisphere. Here you will get curved surface area of hemisphere plus curved surface area of cone. So hemisphere and cone. So now what is the curved surface area of hemisphere? That is formula is 2 pi r square, and curved surface area of the cone is pi r L. Pi r L. So here what is common? Pi common, r common. So in bracket here 2 r left plus here slant height. So common pi r common. So 2 r left and here pi r common. So slant height left. So substituting the value. Here pi is equal to nothing mentioned. So 22 by 7 multiplied by radius. What is the radius here? Radius is here 3.5 by 2. And that is here you can say or we can say 35 by 20 or 3.5 by 2. That is 35 by 20. You can say this is equal to 35 by 20 centimeter. Is it clear? Next, in bracket, here it is 2 multiplied by radius. So we can take it is 3, this is radius is 3.5 multiplied by 3.5 by 2 multiplied by 2. So that is 3.5 plus slant height. Slant height is taken 3.7 approximately. So here we will get this result, and that is equal to, here I am writing, so that is equal to here 22 by 7 multiplied by, when we cut the common ones, here what is common? 7 cut, so 5 left, 7 cut, so here 5 left, 5 cut, so here 4 left, and here it is, or we can cut here, just let me show you here, 22 by 7 multiplied by 35 by 20 multiplied by, this bracket is 3.5 plus 3.7, and that is equal to, here we say 7.2, and that is 72 by 10. Now let us cut there. So we can cut off the common ones here, so that you will come to know. Here as it is, and now cut 7 1 ja 7, 7 5 ja 5 4 ja, so 1 ja here 4 ja, here 2 2 ja, here 2 11 ja, and thus we will get here 11 by 2 multiplied by here 72. Here we can cut this also, 2 36 ja, so 36 into 11 divided by 10, so 36 into 11, that is equal to, here we will get 396 divided by 10. 396, 11 into 36, that is 396 divided by 10, and that is 39.6 centimeter square. This is the area of the top to be painted, and this is approximate, as we have taken approximate slant height. So this is the approximately here 39.2 centimeter square is the area of the plane top to be colored.
Thank you for joining us.